So if you did not get that, make sure you get that How Stuff Works water video turned in. If you need a copy, the printout of this solubility graphs, go ahead and get that done now, because we're going to go over a few of those today. Other than that, get last week's note packet and let's talk about solutions and discuss solubility. This homework that is given today is due Thursday. And that's it. That's what we got. Cool, cool. All right. Let's go over these notes. So last time we talked about water and the bonding that occurs with water. So this time we will talk about solutions. What's a solution that you have at home? What is a solution? Anybody? You ever used a solution? What type of solution have you used? They're pretty quiet here. How about you guys? Contact solution. Contact solution. You put it on the contact for your eye, right? That's also called a saline solution. What is in that? You know? You know? You know? Yeah. No? Salt. Somebody said it, didn't they? I think somebody over there said it. Salt and water. That is a saline solution. Salt and water. Any other solutions that you use at home? WD-40 would be a solution, right? A solution to your problems and a solution in chemistry. What about others? A solution is, chemically speaking, we discussed this last semester, so if you're in my class, you should feel a little shame right now. It's a homogeneous mixture. What does that mean? If you look at it, it looks the same throughout, right? A solution is a homogeneous mixture. What do you mix together to get that? In reality, you can mix many things together to get that. A solution would be the air that you're breathing. It's a mixture of nitrogen, oxygen, and other gases, right? That would be a solution of gas. A solution would be like Gatorade, right? Or apple juice. These would be solutions. Oh, apple juice sounds good right now. These would be solutions. What do you need for a solution? Most of the time, if you want to make a solution, you need two parts. You need the solute, which is what? What is that? The solvent. He wants to go to number 3 first. The solvent does the dissolving in a solution. So if we were to take salt and water, the water would be the solvent. The salt is the solute. It's the substance that is dissolved. The substance that is dissolved is the solute. The substance that does the dissolving is the solvent. What is solvation? It's like many science words. We have ation on the end. Precipitation, evaporation, condensation. What is solvation? Yeah, right? The process of dissolving. I say the term electrolyte. What do you think of when you hear electrolyte? Gatorade, right? Why is it? What does it have? Electrolytes. What are the electrolytes in Gatorade? You know? Salt. Yeah, very good. Very good. When you sweat and perspire, you lose potassium and sodium in your sweat. That potassium and sodium are required to make your muscles move through what's called the sodium-potassium transport chain. If you don't have enough of those, then you get weak and your muscles get spent. They don't work right. So what Gatorade does is it replenishes those electrolytes. These are dissolved ions. Let's take a look at why these are called electrolytes. Very good. We're frozen here. Let me try this. There we go. All right. So here I have hot water, and here I have distilled water. Here I have a light bulb. I'm going to plug this in. Distilled water contains no ions. Turn those lights off real quick. Distilled water, tap water. Take a look. When I put this light bulb into the distilled water, it does not light up because there are no electrolytes in that. Watch what happens when I put it in the tap water. Look at that. It lights up a little bit, doesn't it? That's because tap water has electrolytes. Tap water has electrolytes. Take a look. I've got sugar here. What's the formula for sugar? Louder? C6H12O11. Is carbon a metal? No. I put some sugar in there in the distilled water. Take a look. Since carbon is the first element of sugar, it's not an ionic compound. So it does not change the electrolyte number in there. Here I have sodium chloride, which is salt. Is sodium a metal? Yeah, it's an alkali metal, right? I'm going to take some sodium chloride and dump in there, which is an electrolyte. And remember, this is just tap water here. This is what we drink. It conducts electricity. This is why you don't want to take a bath next to a toaster. Here's just a little addition of salt. Which one conducts more electricity? The one with salt. Right? Watch this. If I add more salt, what do you think will happen? What's that? It'll glow even brighter. Right? That's the electrolytes. That's required in the water to conduct electricity. Turn back on a little bit of light and yeah. So So electrolytes are dissolved ions. Ionic compounds in their molten form or their dissolved forms can conduct electricity. And we got to go back to the other one. Hopefully that works. Good, good. Miscible. Miscible means that things can mix. How many of you like hot wings? Any hot wing eaters in here? All right, Tony, describe to me you eating a hot wing. Where do you go? Home, or do you go to you have a favorite place? Dogs, Wings Express, home. What sauce do you put on there? Tabasco, buffalo sauce. Pull it off the bone, or do you leave it on the bone? Is it on the bone and eats it? Any side sauces? Ranch. That's the proper way to eat a hot wing. They're called buffalo wings because they were created in Buffalo, New York. And basically, they wanted a food that you could walk around with easily and eat. So they gave you a paper boat, little dip of ranch, celery, carrots, and the wings. No utensils, right? And some napkins probably for your pocket. But you eat the wing. The wing has something called capsaicin on it. And that's what brings the hotness to it. The hotness is capsaicin. The capsaicin is nonpolar. Remember our topic last unit, polar versus nonpolar. The capsaicin is nonpolar. That means that it will mix with other nonpolar substances. We call this likes dissolve likes. Nonpolar will mix with nonpolar. So you take butter, you take hot sauce with the capsaicin in there. You mix that together, they mix. They then mix with the fat on the skin of the chicken wing. Right? You put that in your mouth, you bite down on it. What if it's too hot? You drink water, what's going to happen? Water and nonpolar things will not mix. They are immiscible. Water is polar, and water will dissolve other polar substances. That's just going to mix that capsaicin all around your mouth. What do you do, Tony? What else did you say you had? Ranch, right? Ranch. Well, what's ranch made of? Huh? You know what ranch dressing is made out of? Anybody at home know what ranch dressing is made out of? What do they call it? Lump lump? Ranch. Buttermilk. Buttermilk and mayonnaise. That's what you make ranch dressing. All of these are non-polar, so they all mix. Some people don't even like hot wings. They just like ranch wings. They take the wing and directly dip it into the ranch and eat that. I'm like, yeah, I like hot wings. No, you like ranch wings, right? The big question here is, what's the celery and carrots for? Because it's healthy. Yeah, it's healthy. Anybody know? No? It's quite interesting. What if you saw somebody at a restaurant and they had a spoon and they were spooning ranch into their mouth? It looks a little weird, right? What are you doing over there? Oh, my mouth's a little bit hot, so I'm spooning this ranch into it because the ranch and the capsaicin are both non-polar. They'll mix and get it out of my mouth. That'd look weird. Nobody wants to be that guy. So what do? They give you celery and carrots so that you can use those to look less ridiculous as you use the celery and carrots basically to deliver ranch into your mouth. To cool it down, ranch or blue cheese, right? So that's it. That's all the celery and carrots are there for, is a ranch delivery system, so that you don't look weird with your spoon of ranch putting it in your mouth. Pretty ingenious, really, right? Because I mean, we do that at like, there's a ranch dip in a vegetable tray. I'm gonna be all over that thing, right? But with hot wings, the celery and carrots are basically just to deliver ranch to your mouth, because ranch is made of buttermilk, which is non-polar, and all of these non-polar things will dissolve together. Once it gets down to your stomach is so filled with mucus, it's not going to matter. It's not going to hurt you anymore. Well, until maybe the next day when it exits your body, right? Sometimes some of those hot sauces will burn you twice. What's another common thing that people have with hot wings? BW3s. Look across all the tables of BW3s. You see hot wings and what? Beer. Beer. We talked about last week how soaps and detergents can break surface tension, basically making the water not hold on to itself as much. Well, what does beer and soap and detergents have in common? No. When you look at a beer, what do you see in the commercials? Yeah, the foamy head, right? Those foamy head is caused by disulfides. That foam is like a detergent. It breaks those hydrogen bonds and it can actually pull some of that capsaicin out, right? Now, I know you guys can't have beers or whatnot with hot wings, but yeah, that's why it goes together well. Another one you see a lot of times is beer and pizza. Pizza has a huge amount of fat, right? Again, the beer actually cleanses your palate better than water would, because water would just rush over all the fat and stuff that's in your mouth. The beer will actually cleanse that a little bit more. Would wine do this? No, not as much. Vodka? No. It's actually the foaminess of the beer. The more foamy the beer, the better it is. So common beers like Budweiser, American Pilsners, those would be more effective at this. That's why, you know, I mean, there are such things as food pairings with drinks and beverages. And beer and hot wings is just kind of one of those things that goes together nicely. All right. So that's that part. Just think of the hot wings when you're thinking of substances mixing. Non-polar will mix with non-polar, and polar will mix with polar. Let's take a look at these solutions down here. The dots indicate the solute and the concentrations. What is the least concentrated of all these? B. B would what we would call unsaturated. Take a look, here's an unsaturated solution. This is salt and water mixed together. I just took a very small amount of salt and dropped it into some water. That is unsaturated. Unsaturated. Here's another solution. Take a look here. Notice how it blocks the words. That's because there's some salt at the bottom of this. Which one of these pictures shows the one with salt at the bottom? See, that is saturated. That leaves one last. This one is what we call supersaturated. So this is less than the max. This is the max. No more can be dissolved. That's why we have that clump down there. This is more than the max. So you're gonna say, how can we have more than the max? It's a very special condition to have more than the max. Very special condition. It's hard to make it, but we can do it. We can make it. That is this solution right here. This is supersaturated. It has more than the max. Take a look. Watch what happens if I add a little bit more to it. Look at that. It all came out of solution. And now it's actually solid. It's actually solid now. That is a super saturated solution. We added one more crystal to it. How do you think that feels? Hot. If I want to make ice, I need to take heat out, right? Same thing here. It had to lose heat to become solid. So this feels very hot. You ever use those hot packs for snowboarding? Or yeah, if you ever use the hot packs for snowboarding, that's what they use a lot of times. Here's one right here. We can see it's liquid. It's got a little thing in there. If I pop that little thing, look what happens. It solidifies. And it feels hot. Right? It feels hot. So those are the three types of solution. If we want to dissolve something like a solid, if we want to dissolve it quicker, so we want to increase the rate of solvation. How do you dissolve something quicker, a solid quicker? What can you do to the solvent? Stir it. Stir it, increases surface area. Good. We stir our tea, right? We stir our tea with the sugar in it to get it mixed through. What's some other things? There's two more. Home players are quiet today. Make it dissolve faster.
Do you heat it?
You could heat it. Omar says heat it, increase temperature. If we heat it, those particles are moving faster. What else? She said shake it. That's the same as stirring. What's that? You already have water. We want to dissolve it faster. No. So in Great Britain, they use sugar cubes for tea, right? Here, a lot of times we just have powdered sugar. Which one dissolves faster, the sugar cube or the powdered sugar? Powdered, right? If you've ever been and saw like the natural sugar or raw sugar at Starbucks. That doesn't dissolve as quickly. If we crush it, we increase the surface area too. So powdered stuff dissolves faster than big stuff. With liquids and gases, it's different. If I want to dissolve oxygen or carbon dioxide into a liquid, if I heat it, is that going to be better? Take a Coke. Is a hot Coke going to have as much fizz as a cool Coke? No. So it's the opposite. We want to reduce temperature. Makes the gas less dense. In the summertime, if the waters get too hot in the lake or in the creek or the river, there's less oxygen in there and the fish can die. Right? You know those little decorative things? Anybody got a fish tank, an aquarium? Anybody? You know those little decorative things? Like, yeah, like the clam that opens its mouth up, or the skeleton with the rum bottle that keeps drinking or whatever. Those things are oxygenators. Basically, they bubble underwater to put oxygen in the water. They're necessary for the fish to survive in there, right? You also need to have it at a certain temperature. Otherwise, if that temperature is too high, then the fish can die from oxygen deprivation. They can drown, they can suffocate. What's another way to increase?
What did say, Mr. Jackson?
Yeah, Namara.
What does this say? Cool makes, like, I don't know what it is.
It says makes the gas less dense.
Okay, thank you.
You're welcome. What's another way to increase the amount of gas dissolved in a liquid? Think about a soda. Every time you open the soda, what happens? It becomes more flat. Why? Pressure, right? So if we increase pressure over the surface of the liquid, we can dissolve more gas into the liquid. Anybody got a soda stream to make their own soda water at home?
I do.
Yeah, right? Increase the pressure above the surface. Here's my buddy Noah.
Can you go back for a second?
What's that?
Can you go back for a second?
Yeah, after we watch this. Yep.
Okay.
Here's Noah.
Hi, it's Noah, and I just got this brilliant idea to make sparkling wine using a soda stream machine and this bouche de nouveau. Don't worry, it's not for me, it's for my dad. I just got the idea. Almost there. Okay. Okay, now for the part we've all been waiting for. I'm afraid this.
No, just keep holding it. No,
It's gonna explode.
It's okay.
Yeah, okay, that's good.
All right, good. Oh no.
Holy shit!
Oh my god!
The way a soda stream device is yeah, right, Omar. The way a soda stream device works is it puts that pressure above that solution, and that's going to cause more of that carbon dioxide to dissolve into that wine in that case. So increase pressure above the surface. That's the same thing to do with sodas. Every time you open a soda, that pressure is released. So as it sits there, it has to rebuild up that pressure, right? Some of it comes out of solution and rebuilds up a pressure until it's equal. And then you open it again and some more comes out. It's an continuing process. All right, last thing we want to do today is take a look at the homework for Thursday. So what you have on the back of this sheet, everybody got a copy? They're laying right there if you didn't. Is graphs. This is an exercise in reading a graph. So if we take a look, all these different lines represent different compounds. Here's potassium iodide. Here's sodium nitrate, potassium nitrate, ammonia chloride, hydrochloric acid, potassium chloride, so on and so forth. Over here, this is the amount of solute in grams per 100 grams of water. So if we have 100 grams of water, we can dissolve so many grams of solute. For example, for potassium nitrate, we can dissolve 60 grams of potassium nitrate in 100 grams of water at a temperature of 38. So we mark here 60 grams. We go down here, 38. Right? So that means that we could take 60 grams of potassium nitrate, dissolve that in 100 grams of water at 38 degrees Celsius. Does that make sense? Right? So the questions over here are, okay, so what is the solubility of potassium nitrate at 35 degrees Celsius? Well, we know it's 60 at 38, so let's go down to 35 degrees Celsius. We will go up to potassium nitrate, which is right here. At 35, it's about right there. So what is that? 50 what? 54? 54 grams. We can dissolve 54 grams of that per 100 grams of water. Which one is a higher solubility? Potassium iodide or hydrogen chloride? Which one has a higher solubility, potassium iodide or hydrogen chloride? Potassium iodide, its curve is higher, right? Its curve is higher. In reality, hydrogen chloride is going down. Why might it have a curve that goes down as temperature increases? Solubility is decreasing. Well, what did we just talk about? Why might its curve be going down as temperature increases, its solubility goes down? Yeah, right? It's probably a gas. Probably a gas. What if at 38 degrees Celsius, what if instead of having 100 grams of water, we had 200 grams of water? Same temperature, but we have 200 grams of water. How much potassium nitrate could we put in there then? It'll hold 60. 100 grams will hold 60 at 38 degrees Celsius. We have 200 grams of water at 38 degrees Celsius. How much can we hold? We have double the amount of solvent. So how much can it hold? We have 200 grams of water at 38 degrees Celsius. How many grams of potassium nitrate can it hold? 120. If it can hold 60, if it's 100 grams of water, if we double the amount of water, we double the amount of solute that we can put in there. Good, good. I suggest you use the rest of the period to go down through here. That way, if you have questions about it, you can ask me tomorrow during class time. Because it will be due Thursday. Oh, people are chatting in the chat. You know, I don't read that. Yep, Amara, you were right. Sorry, I didn't see it. 120 is correct. So you guys have that assignment for you for Thursday. Thank you. If you have a question, by all means, stick around after the Zoom. Otherwise, I'll see you tomorrow.